Hello everyone, welcome to the ITLS Academy. Today we are going to conduct another topic in the series of food processing, and the topic that we are going to cover is irradiation. Simply, food processing means that when we start our lecture, we have to know that what is this food processing are. So simply, the food processing means that conversion of raw material into the food products. Then after that, we have to consume these food product. Okay. And these food product have a health benefit to the human being, and all the impurities and contamination which are present into that food product will be eliminated. So this irradiation method means that we use our radiation so that it eliminate the microorganism present into the food product and process the food product as a edible form. Then after that, the human being will uh, consume that food product which are processed by that irradiation. So we have to discuss in detail that how this irradiation can help in the processing of the food products. So let's start the lecture. Introduction. Food irradiation is a physiological process. Okay, so for food irradiation is means what? It is a physiological process of subjecting the food to the short wave radiation, sterilization, disinfestation, etc. What we have to do, suppose that this is our food product. Like suppose that this is any cheese. Now what we have to do, we subject these cheese to the short wave, means that the radiation that we introduce to the food product, they have a short wave. Okay, that short wave, either it is radiation, either sterilization, disinfestation, etc. Now this is radiation is considered as a appropriate technology. Okay, we consider that the irradiation that we use for the processing of the food product, they are what? They are a appropriate technology so that they can destroy the foodborne pathogens. Foodborne pathogens means that the microorganisms which have ability to cause a disease to the human being, and it is generated or produced by the food or water. And which type of food and water? The contaminated food and water. Okay, when a human being consume a contaminated food and water, then if uh, due to that, if any disease are occur, then it is considered as a foodborne disease, and the microorganism is known as a foodborne pathogens. which is compared to that heat or chemical preservative. Means that when we destroy the microorganism with the help of irradiation, then they have a more effect for the destruction of that foodborne pathogen as compared to the destruction which occur either due to the heat preservation technique or either due to the chemical preservation technique. So we consider that irradiation is more appropriate. Okay, now come to the radiation which we use for the processing of the food product. They have a low temperature sterilizing technique. Means that the radiation have a low temperature. In this case, sterilization can be affected even at a room temperature. Okay, so you can sterile the food product by the irradiation method even at a room temperature. Generally, when we do a sterilization, then it can be done at a 121 degrees Celsius temperature at least. But when we do a sterilization with that irradiation method, then it can be done even at a room temperature. Here we expose the food product at high energy gamma rays. Okay, we take what? Which type of rays? We take a gamma rays. Okay, and these gamma rays have a high energy. We subjected the food product at high energy gamma rays or fast moving electrons like cobalt 60 or cesium 137 electrons producing machines are the principal source of ionizing the radiation which we use for the food irradiation. It is also considered as a cold pasteurization because it kills the harmful bacteria without the heat. You can kill the microorganism, you can destroy the microorganism, but without any involvement of the heat. That's why it is considered as a cold pasteurization. Now come to the next slide. Mode of action. Here the food are exposed to the ionizing radiation either from gamma rays or high energy electron beam or powerful X-ray. What we have to do, suppose that in a diagram you can see that this is a strawberry. Now what we have to do, we expose that strawberry either to the gamma rays, either a high energy electron beam or a powerful X-rays. Then the gamma rays and X-rays are form of the radiation that share some characteristic with the microwave. The characteristic of the gamma rays and X-rays are very similar to the properties of that microwave, but they have a much higher energy and penetration power. Means that gamma rays and X-rays have more penetration power than the microwave and more energy than the microwave, but they have share a some characteristic with that microwave. The ray pass through the food just like the microwave in a microwave oven, but the food doesn't heat up to any significant extent. Here the rays are passed to the food product just like a microwave are passed in a microwave oven, but in microwave oven the food is heated, but when you use a gamma rays or X-rays for this process, then it cannot be heat the food product as that microwave. Electron beams and X-rays are produced by using electricity which can be switched off or on, and they do not require any radioactive material. So we cannot require any radioactive material for performing this task. Now come to the next slide. Ionizing radiation is the radiation with enough energy to remove the electron from atoms and molecule and convert them into the charged particle. So the ionizing radiation that we use in a radiation, they have enough energy so that they can easily remove the electron which are present into the atoms and molecules, and that electrons are converted into the ions, and ions are what? Ions are the charged particles. Now there are three type of ionizing radiation are approved that we used for the food irradiation. Electron beams are generated from the machine sources, which can be operated at maximum energy 10 millivolt. X-rays from the machine sources operated at maximum energy of 5 millivolt, and gamma rays emitted from cobalt 60 and cesium 135, they have a energies around 1.3 to 0.67 millivolt. Gamma rays. The first is your gamma rays, which is come from the spontaneous disintegration of the radionuclides. Gamma rays are come from the spontaneous disintegration of that radionuclide. Cobalt 60 have 1.17 and 1.3 millivolt energy, which is produced by the cobalt 59. Cesium 137 have an energy around 0.662 millivolt, and they spend a fuel from that nuclear reactor, nuclear waste, and they have a good penetration power. Next is your electron beams. Electron beam have a high energy electron. They are propelled from the electron gun, and they have a maximum energy around 10 millivolt. It is very similar to the beta particle. No waste is produced, and inline equipment. Last one is your X-rays. Beam of accelerated electron is directed at a thin plate of gold or other metal and produces a stream of X-rays exciting from the other side, that is 5 millivolt. No waste is produced, and inline equipment, and they have a good penetration power. Unit of irradiation. Radiation does is the quantity of radiation energy which is absorbed by the food as it passes through the radiation field for the processing. Radiation is what? Radiation is the quantity of the radiation when our energy is absorbed by the food product, and it passes through the radiation field for the processing. The gray is the unit used to measure the radiation, that is your GY. 1 gray is equal to 100 radiation absorbed, or 1 kilo gray is equal to 100 gray. According to the good manufacturing practices, at any dose, if it is above in 10 kilo grade, then is safe for the consumption. Scope of radiation: disinfection, shelf life extension, decontamination, and product quality improvement. So irradiation can be used in a disinfestation, means that the elimination of the microorganism from the surface. Increase the shelf life. Use in a decontamination, means that the food products are contaminated by the other sources, like from the hand, from the chopping board, from that knife, or from the surfaces, and it also improves the product quality. Terminology used in radiation treatment. First is your radioization. Radioization is the process which involve a irradiation, which is applied to obtain a substantial reduction in the number of spoilage organism, thereby extending the shelf life of the food product around 3 to 4 fold. And it is applied according to a dose that is around 0.5 to 10 kilogram. Radiation. Radiation is aimed to reducing that considerable number of non-spore forming pathogen microorganism and parasite. Means that when we do a radiation, then they targeted the non-spore forming pathogens and parasite, and here the dose is applied around 3 to 10 kilo gray, and improve the hygienic quality of the food, and it reduces the risk of exposure to the pathogenic microorganisms. Redaperatization. It also referred to as a irradiation which is applied to the pre-packed enzyme inactive food. Suppose that we have a food product in which the already enzyme are inactivated and they are already packed. Then it reduces the number and activity of the microorganism. For example, 12D reduction in Clostridium botulinum spore, and it apply at doses around 25 to 60 kgY, and this process is rendered the food shelf stable without any refrigeration. Benefits of the food irradiation. It extended the shelf life of the product, less food spoilage, reduce the risk of the foodborne diseases. See, when we do a irradiation, then obviously the shelf life is extended. And when the shelf life is extended, the food will spoil less. So it decreases the food spoilage and also reduces the risk of that foodborne diseases which are caused by the microorganism, that is your Campylobacter, Salmonella, E. coli, and Listeria. Means that when we do a irradiation, then they have a targeted the microorganism, that is your Campylobacter, Salmonella, Listeria, and it also need a less pesticide, less need for some additive like preservative and antioxidant, lower risk of importing or exporting insect pests which are hidden inside the food product, reduce the need for the toxic chemical treatment such as used to kill the bacteria found in some spices, and also reduce the sprouting in the potatoes, onion, and herbs. Effect of irradiation on a food product. Some food product like your dairy foods and egg, they can't be irradiated because when we do a when we apply a radiation to that food product, then they change their flavor or texture. Fruits, vegetables, grain food, spices, meat, they can be irradiated. Irradiation also cause a minimal changes to that chemical composition of the nutrient, but it can alter the nutrient composition of the food because it reduces the level of that vitamin B. And there is some this loss is very similar to that occur when food is cooked or preserved in more traditional and accepted way, that is your canning or blanching. So this is all about the processing of the food product by the irradiation method. I hope you will understand, but if you have any query related to this, you are freely to ask me in a comment box, or for a further detail you can follow the ITLS Academy on different platform, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.